I think we were to talk about the factory pattern, and there are a few variations of this pattern. You have a simple factory pattern, and you have the abstract factory pattern, and you have the factory method pattern. So we have kind of like three patterns that revolve around the same kind of problem with some different flavors to it. So who should create an object if the grasp creator pattern is not a good choice? So in the grasp creator we had a small list of scenarios that specified how we could, for example, create objects and who should be responsible for the creation of an object. For example, if since the cards are part of the deck, it's natural to let the deck create all the cards that are in it. So the factory pattern can then be used if you have some more advanced requirement regarding the creation of objects. For example, maybe we need to parse some kind of settings file or something like that to know what kind of object we're actually going to create. Then the factory pattern is good to use. And the idea is to remove the responsibility to create objects and add it to maybe a new class and call this class factory in some way. So instead of creating objects directly using new, we use some other object and ask it for, could I get the X object? And it does its work, parses the file, does whatever it needs to do to know what type of object it's supposed to create and return it. So, and for the abstract factory, we let the factory implement an interface. So we create an interface for the factory itself. So we can have several different kinds of factories that can create different kinds of families of objects. And maybe this is not totally clear. So the structure is like this. And that's probably something you can understand immediately. No, not really, I guess. So the first thing is that we have these families of products. We have the products that start with A and B. So we have interfaces for these types of products. And we have two implementations of each of these interfaces. This class implements this interface, and this class implements that interface. And then we have an interface for the type of factory. So we have this create object type A and create object type B. And this one returns an interface of that kind, an object that implements this interface, and this other, an object that implements that interface. And then in the concrete factories, this factory creates those two types of objects that implement those two interfaces, respectively. And this other type of factory creates this and this types of products. So this factory, this concrete implementation of the abstract factory creates objects of this family, and this other factory creates objects of that family. So the client then can use an abstract factory and these interfaces instead for the products. It does not know the concrete factory, and it does not know the concrete products. And that's the advantage of the abstract factory. Maybe an example will make things a little bit clearer, at least an example in theory, so to speak. So we could imagine that we have our controller class. So we have an object of type controller, and we have some kind of view. present add member form. So in some way the controller has got knowledge that, well, the user would like to add a new member. So all right, what am I supposed to do now? Well, I'm supposed to tell the view to present the form for adding a new member. And all right, the view creates a window, text fields, and button. So it creates a form and shows this to the user and waits for input, and when the user has clicked OK, well, the whole information is returned to the controller, and the controller can do something with that information, add it to the model. So the idea now is that we would like the view to be oblivious of the type of user interface it actually uses. So we could imagine that our system is supposed to work on Windows, it's supposed to work on Mac OS, it's supposed to work on Ubuntu. And these all have windows and buttons and text fields. They are present in this on these platforms and have libraries to do this. But in our code, we cannot kind of like add if statements, of course. If this is the Ubuntu platform, then I should do these kinds of calls with these kinds of parameters. And we would like to encapsulate that, of course. So the idea is then to create the product interfaces. So we create an interface for a button class, and we have the Mac OS button and the Ubuntu button and the Windows. So in these classes, we can then encapsulate the platform-specific code and let it fulfill the more generic interface that the view actually works on. So the view works on the button. And the same thing for the text field and for the window, for example. So these are the products. The next step is to create the factory. The interface for the factory. And here we have operations like create button, create window, create text field. So this is the interface, and then we implement it in 3 different variations. You have Mac OS factory, Ubuntu, and the Windows factory. So, and of course, in when create button is called and it happens to be a Mac OS factory that is used, it of course returns the Mac OS button. It creates such an object and returns it. But for the client, for the view, he only sees this that he has a factory that can create this object. He does not know if it's a Mac OS factory, or a Ubuntu factory, or Windows factory. And he knows that, okay, I can create a button. I will get a button that implements this I button interface, but I don't know if it's a Mac OS button, or Ubuntu button, or a Windows button. This means that we can plug different types of factories into the view, and it will just work. And we can implement these GUI elements in different types quite easily. And if we would like to support a new platform, okay, we implement a new factory for that platform, and we implement the user interface elements that fulfill the interfaces that we need, and we can just plug it into the view. So instead of the view knowing the details of each and every type of user interface technology, we use the factory to let it create these elements instead. Maybe a little bit more understandable than that amazingly confusing slide. And this is exactly what this slide tries to tell you. We have this abstract factory, GUI factory interface with create button that returns an I button, and create window returns an I window, button and window. And this would be Mac OS factory, and this could be Ubuntu factory, something like that. So, using the abstract factory, we hide the concrete classes. This promotes encapsulation, so the client does not need to know about the details of the products or factories. Promotes consistency of objects, because it could be bad to try to create a Windows type button and let it be inside a Mac OS window. It probably will not work. And having a factory to be responsible for all these creations lowers the risk of creating incompatible objects. It can be hard to add new products because there are a lot of changes. If you add a new product, you need to implement the new creator function in all factories. So the whole becomes kind of like, okay, it's like the least common denominator. For example, if we have some fancy GUI widget in Mac, and that's not present in the other two platforms, it can become really hard to actually use this new GUI widget. Because, okay, we need to create some kind of interface for it, and maybe we need to just add some older type of widget or whatnot in the other platforms that does not have this cool widget. And this can be very, very hard in some cases. So, all right, let's go back. Factory method. This is simply the use of a polymorphic operation to create objects. So, for example, if we would need a new type of object that is, and the client that would like to have this object only has an interface to rely on. It does not really know what object what type of object it has. It can't do new on anything. I don't know what type of object I have. I would like to have a copy of this object, but I don't know what concrete class it actually is. And we, of course, don't want to use runtime type information or something like that to find out. So what we do then is that we simply create a new method in the interface, clone, for example, or something like that. And in the concrete classes, we just use this to return a new copy of the same type of object. And this is exactly what the template method actually is. So factory method is template method for creating an object. Just use a polymorphic operation to encapsulate the creation behavior instead of using the constructor. So actually, we should do some implementation also. And what we will do is we will take a look at the code once more for our little game. And if you remember, we used a parameter here to the dealer for the rules. And maybe this is not the best type of implementation here, because you have all the way here in the console, the start of the program. This is starting to become quite big, I think, too big maybe. And having different types of rules created here is maybe not that good. So we should encapsulate this behavior rather in a factory. And we can imagine the idea that, okay, we need to read from a settings file what type of rules we are actually to use in this application right now. So it will become easier for us to ship different variations of the game to different types of customers, because it will only require a new setting. And then we would need to add this file parsing here, and that's maybe not a good idea. So we will do this using a factory instead. So, all right. And it won't be an abstract factory. It will be a simple factory. And it's quite easy, actually. Something like that, I think, would do it. So, simple factory, one method. We could imagine that we would add our other three variations to do this inside this factory also, and this advanced behavior also of parsing a file somewhere in this class. So instead of the dealer taking we ask the factory for it, and inside the program we don't create that, we create And we should have the European rules, so no hidden card, and instead of when to switch, instead we do this. And now we have the hidden card. So instead of having this outside in the program class and adding more advanced behavior, we put it in the rule factory class and let it be responsible for creating rule types of objects. And one more interesting thing here is that these concrete classes do not need to be public anymore. So we can encapsulate them even further, because the rule factory is part of the package. It can create instances of these classes, but someone on the outside cannot do it. So we minimize the risk of someone doing new American new game strategy somewhere else where they should not be able to do that. And that is a good thing. So we can increase encapsulation also in this project. So this is a good thing. In C#, it's a little bit more messy, and not all programming languages have good support, at least, or easy support for doing this type of encapsulation. But in Java, it's really easy, and it's a good practice to not just let everything be public. Because this is, well, if people can make mistakes, they will make mistakes. So if you have this one open and this one open, somewhere someone will do new on it instead of using the factory. All right. Factory has been talked about, discussed, and implemented. And the next pattern we're talking about is the facade. How can we protect a subsystem from unwanted changes, access, or dependencies? And the idea is to design a good-looking single point of contact to the subsystem, a facade. Exactly as in buildings, you walk down a street and you see this good-looking, nice facade, and you don't really know what's on the inside. And this is the idea of the facade pattern also, that, okay, it's messy maybe on the inside, but at least the users of this mess should not see the mess itself. They should see the nice facade instead. And typically it's used in a subsystem setting. So we have this kind of new concept of a subsystem. It's not really that well defined, but it's something that is more than a single class, at least. For us, we can think of the subsystems as the packages maybe in the architecture. So we have the model subsystem, the view subsystem, really small, and the controller subsystem, that's also really small. And also, we could think about the rules as a type of subsystem. So, actually, in our little dice game, we have this kind of like problem of the controller being able to do lots of stuff. It can access both the dealer and the player directly. It has access to them. This creates dependencies that we maybe do not want. We can maybe do some weird or unwanted stuff inside the controller. We also have this, as we saw in the program class, we have this, well, okay, it needs to create some objects, and maybe more objects than we actually would like. And if we'll take a look at the controller, well, arguments here are growing. We have both the dealer and the player. And there is actually nothing that just protects the model from the controller doing something like this. So the cards of the player are wonky in some respect. So and as I said, if you open up the possibility for someone doing something wrong, they will do something wrong eventually. It's just a matter of the amount of developers and the amount of code present actually and time. So stuff like this happens. And if we can design our application so that it removes the even that you cannot insert errors inside the code at all, it's of course better because it won't compile. So it's obvious that the controller should not be able to do these stuffs on the dealer and the player. So we will instead design a nice looking facade for the controller to work with. And this this will require us to do some to add some code actually. So new file game facade. And one really funky thing we can actually do in the controller right now is to, well, start new game and I send in the dealer here instead of the player. Because the dealer is also a player. So when implementing the controller right now, you really need to take care. All right, so instead of doing handling the dealer and the player here, we kind of like just would like to send in the game facade instead. And instead of doing this, we just move this functionality to the game facade. And do this. Was it like that? Start game. So we can simplify the code here. And the same thing in this one. And the same in this one. All right, we also need to have some functionality to get the score of the dealer and the player, and get the hand of the dealer and the player, and know if the game is over. So I will add these also. So get score is more get dealer score. DRL. All right. We can also ask the game if it's game over. So controller. Is game over. And we also need to check if the dealer is the winner. And we need to get the hands also of the dealer and player. So I think we should just player. Show hand, get hand. It should be here somewhere. All right, something like that, and back to the controller, a game. And I also think we need to move this into the facade. Like that. Remove this. Let's compile. Oh. So, we simplified things a little bit for the program class. So, we have less complexity here now. We simplified things in the controller. We have less complexity here now. One could even maybe take these kind of like complicated if statements and put them inside the facade also to service the controller even better. That's a thin line though on how much you should service a specific controller. Anyway, but we have moved the complexity to the game facade instead. So we kind of like get some benefits in some places, and we get some complexity in another place. So it's more or less a matter of where you would like to move these things. And in our case, I think it's a good idea to move this complexity to something inside the model instead, because we have get better architectural clarity, so to speak. If you remember back to kind of like one of the first lectures about architecture, we said, oh, we should define these cohesive parts of the system and have as few couplings as possible between these parts. And we have definitely made the model more cohesive and got rid of actually one coupling from the controller into the model. So using the facade, we can increase encapsulation, and we can remove some dependencies. And in our case, we could remove dependencies on the architectural level. So instead of having these two, we will now have a dependency to the facade instead. So let's add that. Game facade. Can we remove this? Yes. Yes. Let's move that one there. But on the other side, inside of this, we have the player. Oh, those are actually associations, since they are members. And also the dealer. We should, of course, add role names and such to this. And we also have a dependency to the card. So, as we can see, almost everything has dependencies to the card. Not that surprising. Possibly it's even so much that we should just remove all these dependency arrows, maybe, just to make the class diagram a little bit better, and write somewhere that, well, everyone has dependencies to the card, so they don't really, these arrows don't really add that much. However, in the workshop, you will actually remove some of these dependencies also. So this kind of like shows that depending on what you would like the reader to know by looking at your diagram, you need to tweak the diagram so that it shows what it's supposed to show. And this means that you probably need to create several types of diagrams for different situations. You can't have one diagram to rule them all, so to speak. So if we would like to show, okay, I'm more interested in how the game rules and the dealer use the game rules, well, then maybe I should focus on this part in the diagram and not have all these dependencies to card everywhere. That just kind of like clutters this image. On the other side, if I'm looking for a refactoring that has the card involved in some way, oh, I would like to remove dependencies to the card, maybe from these types of classes, then I need to see them so I can know what to remove and find opportunities for refactoring. So depending on what you would like to do, you need different types of diagrams, of course. All right. I think actually this was the last pattern that we will use in the blackjack game. I have not seen any really good ways to cram more patterns in here right now, so we will be doing some other small examples in the next lecture. So questions, and you can see we have strategy, we have facade, we have the factory also should be added. The rule factory, and it is used by the dealer. It is used by the game facade, and it in turn uses this interface. And now I don't really remember, but maybe we are using the American type of rule. So this is the full design, I think, of this blackjack game right now. And as you can see, we have actually managed, I think at least, to have this quite cohesive model package. Things are kind of like stuck together here, but we have quite loose coupling between the architectural elements of the view and the controller into this model. And that's really what we would like to achieve. So the view only knows about cards, fine, and the controller only knows about the game facade. That's also good. And inside here, we do have some issues that you will take a look at in the third workshop to make this a little bit better. Well, no, we can't really say that the model in itself has high coupling, but we can look at specific classes inside the model and say that they have a high amount of coupling. So, for example, the game facade is coupled to the player and the dealer and to the rule factory and, well, also to the card. So, starting to become big. On the other side, facades are kind of like known for this. It's hard to design a good facade without adding couplings to it, and it's easy for them to become quite messy on the inside, but they should present a good interface to the outside. So that's the whole idea of the facade. So we can't win every battle, so to speak. And he also in the book argues that, well, you should pick your battles. What is it that we actually would like to have loosely coupled? Okay, we'll probably not like to have couplings going out from the card class, because this is a definite reuse candidate for other projects. It's a generic type of card class right now. Adding some kind of coupling to the player or to the dealer or somewhere else would not be a good idea. And maybe the same thing is with the deck, that, okay, the deck and the cards, well, they can be easily reused right now. Maybe also the player class can be reused. So if we have a new type of card game where we have a player that has cards in his hand, player is definitely a type of a reuse candidate. But it surely becomes harder and harder to reuse the stuff the more outgoing couplings you have. And also, for example, making a change in the card class could potentially affect everything in the design right now. So we, of course, need to be aware of this when we look at our requirements, and we are supposed to guesstimate how long will this change take. Can you have it ready tomorrow, on Wednesday, on Friday, next week, 2 months? Okay, this will require us to change the card class quite radically. Oh, things are going to break. We need to rewrite a lot of code in almost every part of the application. All our test cases, maybe. So maybe we should take some extra time if we have such a change that we would like to do. So using these types of diagrams, we can estimate things better. We can communicate. We can find opportunities to make refactorings, and in Workshop 3 we'll make one such refactoring that will remove some dependencies to the card. And maybe this is something that if you get the requirement, okay, we need to change the card class now. So maybe we first should do a refactoring to remove some dependencies to it, because this will make our job easier later on. And such opportunities can show up if you make this very detailed type of diagram, or generate it, or find it out in some other way. But we can definitely find classes inside here that has a high amount of coupling. That's correct. And high amount is also, of course, relative to the other classes in the design, maybe. All right, I think it's time for a break. So I don't know if we have some, yeah, here we have the facade structure. This was kind of like what we did. We had player and dealer as the service classes. Quite simple, actually, in our case. In other cases, you have maybe a lot of classes here on the inside, and it's really, really messy how you do things. But for the clients that use the facade, they just use this service interface of the facade and just sees this nice looking stuff. And on the inside, it could often be quite messy. So we move complexity from the clients to the facade. We saw this, that we moved some complexity from the controller into the facade instead. So it's better for the client, potentially worse in total. But we have moved complexity from a place where we do not want it. So this is the trade-off you often need to do. We can increase encapsulation. We can possibly need several classes to do this. Could have several types of facades for different types of interfaces. It's often not a good idea to create a facade for the whole model, so to speak, because it would probably be quite big. So you need to chop up your facades often in different packages, so to speak, or different classes to service different types of clients. And it's hard to design these facades well without detailed knowledge of both clients and services. So in our case, we did this not before we did the implementation, but after we actually had some concrete information on, okay, what does the controller really need? So finding the interface of the facade can be quite tricky if you don't really know what you're doing. And you probably don't before you have implemented at least some parts of this. Also, the balance between what should we move to the facade and what should be left in the clients can be quite delicate also. In our case, I kind of like drew the line just by having some kind of feel for it. So I did not want kind of like this expression inside the facade. I could have, of course, have added some kind of present complex menu Boolean stuff in the facade, but it would then be quite tweaked towards a certain type of user interface. But of course, if we find that we have several different controllers that all have this if statement in common, this expression in common, then maybe we should move it to the facade anyway, because it's not good to have these kind of like complex statements spread out. So it can be a tricky balance to find there on how much complexity we should move into the facade. In our case, as I said, I wanted it to be focused on the model responsibilities, not add responsibilities that has more to do with the user interface.